Hey again, it's Mr. Lum, and we're going to continue with Chemistry 11, and we're going to be doing some more naming of ionic compounds. But this time, instead of naming just ionic compounds, we're going to be doing it when an ionic compound has a water stuck to it, and these are called hydrates. So how does water stick to some ionic structures? Well, in the process of making some of these ionic structures, like by using evaporation or recrystallization, water is often stuck to these ionic molecules or ionic compounds, and it adds some mass and some size to that molecule, and therefore it has to be taken into account. And therefore we can also name these ionic structures when they have a water molecule or several water molecules attached to it. And this is called a hydrate, when some water molecules are attached to an ionic compound. So here's a question right here, and it says aluminum oxide is dissolved in water. Evaporation is used to create crystals, or in other words, aluminum oxide crystals. And what they have found is that there are 3 water molecules are attached to each aluminum, to each aluminum oxide. So we're going to fix this question right here. Oxide molecule. So that should go right there. So before we get started, let's just do a little bit of review and talk about aluminum oxide. So we know how to name aluminum oxide from our previous lesson. We just take aluminum, or write the formula for aluminum. So Al is 3 plus, and we got that right from here, right from our periodic table. So here's aluminum, and it's 3 plus. We have oxygen right here, which is 2 minus. Okay. We see that our aluminum is not multivalent. It only makes one ion. So therefore, when we write aluminum oxide, we're just going to go like this. Al, then we're going to write O, and this one is going to go right there, and this one is going to go right there. And so it's going to become Al2O3. Okay, so here's aluminum oxide. Now, the next thing it says is that there are 3 water molecules that are going to be attached to each aluminum oxide molecule. So here's our 1 aluminum oxide, and so what we're going to write here is we're going to go times, this has attached to it 3, and we're going to write a big 3 waters, 3H2O. And so this is how we write the formula for aluminum oxide with 3 water molecules attached to it. Okay, so that is the formula that we write. Okay, it's a big 3, not a little 3. And this means like multiply to, or means attached to it. Okay, now how do we name this? Well, we already know how to name this part right here, Al2O3. It's just aluminum oxide. It even gives us in the question here. Okay, now we have to write 3 waters. So if you remember from Science 10, well, you had to do some covalent naming, and we had to, instead of saying 3 waters, you had to count in mono, di, tri. So we're going to use 3, or in other words, tri. And instead of saying water, tri water, we're going to say trihydrate. Okay, and that's what it means. It means aluminum oxide trihydrate. Okay, let's get some more practice in here. So here's 3 more questions. You can try putting the video on pause and try answering some of these questions yourself. But we're going to get started here. So we have copper 2 sulfate pentahydrate. So we have copper. Copper is way over here. 2 sulfate. Now I don't have sulfate on here, and you won't find sulfate in the periodic table. Sulfate is a polyatomic ion, and it looks like this. SO4 2 minus. Okay, so we have copper 2 sulfate pentahydrate. So which copper is being used? Well, it tells us that the number 2 copper is being used. So right here is the one that's being used. So we're going to write this Cu. Now the number 2 is being used, so I'm just going to write up here. And we also have SO4 2 minus is being used. Okay, so if we cross multiply this, or bring this down, it's going to look like CuSO4. This is going to be a 2 right here, or sorry, coming from here. This is going to be a 2 right here, and this is going to be a 2. But since they're the same, well, we can kind of have a common denominator, so it's going to be CuSO4. Okay, because when you think about it, this is going to be a 2 plus charge, 2 minus charge. It is completely balanced. And so it says now pentahydrate. Penta means 5. Hydrate just means water. So we're going to go 5H2O. And that's our answer. Okay, next one. We have iron 3 chloride. So again, we have iron. Now this one is, we're going to be using this one up here, the 3 plus. Chloride, right here. Hexahydrate. So first let's write this. Fe3 plus Cl minus. So I'm going to write it down here. FeCl. This is going to go down like right here, and this one is going to go right there. So this is going to be a 1 and a 3, like that. We don't have to write those ones, we just can leave it blank. So I'm going to rewrite it again and write just FeCl3. Okay, and then it says hexahydrate. And if you look on the chart before this, hexa means 6. Okay, so it goes mono, di, tri, tetra, penta, hexa, heptaocta, nonadeca. Okay, but we only need to know this hexa right here. So it's going to be hexa, or 6, hydrate, which means water again. So iron 3 chloride and 6 water. Iron 3 chloride hexahydrate. Okay, next one. We have calcium. We're going to be using SO4 again. Calcium is 2 plus, SO4 is 2 minus. So without doing this stuff right now, you should probably get used to it. You can just write down, this is a 2 plus, a 2 minus, same, we only need 1 calcium and 1 sulfate, and it's all going to be balanced, so it's going to be just CaSO4. Oh, what am I writing? We already have this. Sorry, Ca is calcium. I'm going to write calcium like this. calcium. It is not polyatomic. It's only 1, 2 plus, so we don't have to write any numbers in here. SO4 means sulfate. So it's going to be calcium sulfate. 2, water. 2 is dye. Dihydrate. Calcium sulfate dihydrate. Okay? And that's it.